parametric coordinates. So in this extension part of looking at the parabola, we introduced this idea of parametric coordinates. And all parametric means is pair of measures. Okay. Now, we're used to looking at Cartesian coordinates. And so we have an equation for a curve, and we'll say that this is the point, I don't know, 2, 4, whatever it happens to be. We have an x value and a y value. So we have one equation, and the points are described by two numbers. Parametrics is sort of like the other way around, where we can describe the curve by two equations. One equation for the x value, and one equation for the y value. And then we can represent the point with just one number. And then we substitute that into both of the equations to work out whatever the coordinate is. Now that number that we substitute in is what's called a parameter. So that's what's known as the parameter. So let's have a look at an example. Here's our good old standard, and now we've seen it as x squared equals 4ay. We'd like to see it in, and we can work out focus and directrix and all that sort of stuff. But that's the Cartesian equation. The parametric equation is that, 2at at squared. It's still the same curve, but the difference is, rather than knowing the equation for the whole curve, we just have an equation to work out the x coordinate and an equation to work out the y coordinate. And where this is really a useful idea is, how many people are doing physics? Yeah? You know how you deal with vectors? And if a vector is at an angle, you have a horizontal component and a vertical component. And so it's the same sort of idea. It's saying, well, instead of looking at the curve, all I'm interested in what's happening in the x direction and what's happening in the y direction. And later on with the maths, where that becomes really useful, is in another topic called motion, where we start looking at it. And it's so much easier to study motion when it's just travelling in a straight line. And so if something's moving off into a curve or something like that, we can always break it down into what's happening horizontally, what's happening vertically. And so we break it up into a pair of measures, or parametrics. So I guess this is the introduction of that sort of idea. So for our standard x squared equals 4ay parabola, we've got 2at would be the equation for the x value, and at squared would be the equation for the y value. So here's a point on the parabola which would have coordinates 2aa. And that works because if we substitute it into x squared equals 4ay, we can see, yep, that works. Well, that's if I'm dealing with a Cartesian. In parametrics, it would simply be the point t equals 1. Because if we substitute 1 into the x equation, we get 2a, the x value. And if we substitute it into the y equation, I get a, the y value. So it's just a different way of describing curves. Okay, so there's the parameter of that point would simply be 1. And then over here, there's another point, minus 4a, 4a. It would have the parameter negative 2. Okay, so any point on our standard parabola, x squared equals 4ay, has those parametrics. The x will be 2at, and the y will be at squared. Now, the nice thing about what we look at as far as the parabola goes in this topic is we don't shift it. It's just the standard curve we look at, x squared equals 4ay, for all the things we want to do in the extension part. Okay. So a is still the focal length. That hasn't changed. And t is just any number. We can substitute any number in and we get a point on the curve. Well, it doesn't just have to be parabolas. Any curve can be broken down into its x component and its y component. So suppose they gave me this equation, x equals a half t, y equals a quarter t squared. Oh, actually, I think that one does turn out to be a parabola now that I've said that. But I can always find out the original equation by eliminating the parameter. I could make t the subject in one, substitute it into the other, and then I'd find out what the equation is. It just turns out to be our standard y equals x squared parabola. That's all we really need to do if we want to find the equation. So what's the coordinates of the focus? Well, we can still do the same sort of things. A in this case is a quarter. And so the focus is 0.25. So what would be the parametric coordinates for y equals 8x squared? If I want to put it in the standard form, well, x squared equals 4ay. The common mistake is to go, oh, 4a is 8. But it's not, because remember we want x squared the subject before we do this. So x squared equals 4ay. If I've got it in that form, a is actually 1 on 32 for this one. So the parametrics that will work for this one, and I've actually written them as a coordinate, but there's the formula for the x value. 2at, so 2 times 1 on 32 is 1 on 16 times t. At squared, well, a is 1 on 32, so 1 on 32 t squared. And so sometimes you actually see the equation of the curve when we're dealing with parametrics actually written like a coordinate, where they say, oh, well, this is the x formula, and they put it in the x position in the coordinate, and this is the y formula, and they put it in the y position in the coordinate. Okay, so today is just a little introduction there into this idea of parameters.